close out today's lectures by talking about variable importance. And so we haven't really talked about how to plot these ensemble models. And because they're sort of a combination of a whole bunch of trees, it can be kind of hard to plot something with these. But one thing that you can look at with a couple of these models is the variable importance. And what that means is basically how much individual variables end up contributing to this ensemble model. Because these models are essentially like conglomerations of multiple smaller models, it can be sort of difficult to visualize or think about how a single variable plays a role. And so we can quantify basically how important a variable is to the overall ensemble, and then we could plot that as sort of a way to demonstrate what's going on under the hood. So for bagged or random forest regression trees, we can calculate variable importance by recording the total residual sum of squares that's decreased due to the splits of a given predictor, xi. And then we could average this across all of the B trees, and so across all of the trees that are fit. So basically you record how much that given predictor decreases your overall sum of squares across all the B trees. And so what's going to happen here is that a large value is going to basically indicate that this variable is important, that it kind of plays a big role on average. Similarly, for classification trees with bagging or random forest, you can add up the total amount that the Gini index is decreased by splits of a given predictor xi, and you could average these over the B trees. So here's how you would do that in R. So there's a couple things going on here, but basically the most important one is that you're adding this argument to the set engine. So we haven't really done anything in set engine yet besides specify the package that we're using to fit these models. So here I'm fitting a random forest. I'm doing classification. This is my heart disease model again. I'm setting my M try, my number of tries, so my M, that's my M variable, to 3. And so this is using basically that default where my number, my M is going to be the square root of P. And so if we round down, that's going to be 3. And then I'm going to pass this importance equals impurity. And so what that does is basically if there are certain arguments that you'd like to pass to a function that aren't built into the tidy model's specification, so like random forest here, you can pass them via the set engine as long as the package underneath knows what to do with them. And so luckily the Ranger package has a way to deal with this argument. And what it's doing is it's letting that function know that you are interested in variable importance, and so it should save information about that in each of these model fits. And you can specify what you'd like that to be, and by default it's going to be impurity, and so that's what we're going to use. And what that means is this impurity measure, if you remember when we talked about the Gini index at the very beginning, we talked about it as a measure of purity. And so by setting importance equal to impurity, you're basically saying that you'd like to use the Gini index as what you use to assess variable importance. And so that's the only thing that's going to change from what we've done so far when we're fitting our model. We're just adding that importance equals impurity statement. And we still would fit our model like you normally would. So here I'm just fitting a basic model using that random forest specification. I have my model, my formula here. My data set is heart. You could do the same thing, and instead of using the fit function, you could be using fit underscore resamples or tune underscore grid, and you could still kind of follow the same procedure. And then to pull out the importance of each individual variable, we're going to use a function called importance that comes from the Ranger package. So I'm not sure if I've shown you this before, but basically if you use these 2 colons, it's shorthand for saying I would like to use this function from this package. So the thing to the right of the 2 colons is going to be the name of the function, and the thing on the left is the name of the package. And then you're going to plug in model $fit because we want to pull out the fit portion of this model and plug it into that function. So this is kind of like when we did rpart.plot and we wanted to pull out the fit object in order to do it. Just to make sure it's clear, this code here is doing the exact same thing. So it takes one extra line, but you also could equally just call the library Ranger. So I could load that library, and then I could use the importance function exactly the same as I did on the previous slide. And so basically, the times when I do this, where I just call, instead of loading the library, I just call the function using the double colon. I sometimes do that if I want to be very explicit about where I'd like that function to come from. And I also sometimes do it if I'm only using one function from a package. Instead of loading the whole package, I might just pull out the one function. But either way is totally fine. So this is doing the same thing, loading the Ranger library and then using the importance function. And so what we can see here is it gives us an importance measure for each of the variables. And so, for example, this variable here seems to have the largest importance. And similarly, it looks like this one, FBS, has the smallest importance. And so I can save this importance, and so I'm just saving this, this vector here as an object called var_imp to indicate that it has the variable importance. And so all I'm doing is saving this into an object called var_imp. And now I want to put this into a data frame. And the reason I want to put this into a data frame is because I want to be able to plot it. And our ggplot functions work best if we use a data frame. So now I'm taking that var_imp, that's this right here. And I'm going to create a variable. So I'm creating a data frame here. So data.frame will make a data frame. And my data frame is going to have two variables. One is going to be called variable, and that's going to be set equal to the names of the var_imp object. And so that's going to basically be this age, sex, chest pain, resting blood pressure, etc. So that's going to be variable. And then my second variable in this data frame is going to be importance, and that's going to be equal to the values in this vector here that I just pulled out of the importance function from the Ranger package. So now I can take that data frame and I can plug it into a ggplot where I can set my x to equal to the variable and my y equal to importance to be able to plot this using geom_col because I'd like to create this column plot. Okay, how could I make this plot better just looking at this plot? Well, probably the first thing you notice, and what I noticed too, is it's kind of messy down here on the bottom. Got a lot going on here. You can't really read it because they're all kind of overlapping. So one thing people sometimes do is you could rotate your axis. You can rotate these labels so that it's easier to see, so they're up and down. But I don't love that option because I don't really like tilting my head to be able to read my plots. Something that I prefer to do is actually just to flip the whole thing so that it's super easy to read because they all just stack in a way that's kind of sensible. So to do that in ggplot, you can use this chord_flip, and that flips the coordinates so that you end up with this nice plot that's flipped. Okay, when I'm looking at this plot, there's one other thing that I think I could do that would make this a little bit better. So the final thing that I would do is I'd probably want to order these because that makes it really easy for the viewer to look at this and say, hey, I know exactly what the important variables are because they're ordered. I don't have to sort of, eyeball it by looking at this and seeing all the different ones. I can see exactly in order from least to most important. And so to do that, you're going to have to do a couple quick things. There are easier ways to do this or quicker ways to do this that involve other packages. But with the packages that we know so far, the best thing to do would be just to set your variable, it's a little bit redundant, but we've got a variable called variable in this data set, and I'm going to make that a factor. And when I make that a factor, I'm going to want to set specific levels, and I want these levels to be ordered. And so what that's going to do is it's going to let ggplot know the order that I want them to be plotted in. And so this is going to say, I want the levels to be equal to variable, but the order that I'd like for these levels to be in is in order of importance. And so what this does is it sets the levels equal to the values of the variable, but it orders those values in the order of importance so that you see from biggest to smallest of variables that are the most important. So this is what you get for your plot. I think this looks pretty good. It gives us a nice idea of which variables are used the most in our models, and it can be really informative if you're handing this to a stakeholder so that they can kind of see what variables ended up playing a role in your ensemble model. So that's all for today. We're going to practice some of this in the lab on Thursday, so you'll get a chance to try this out yourself. But if you have questions, feel free to reach out to me on Gitter or on our GitHub community page. Oh, and today I sent an email to all of you that requested to get an email at the beginning of class. And so if you did not get an email from me, it's because I must have missed you. I missed your email to request to get on that email list. And so please just send me another email so that I can make sure to get you on the list.